Hello, and welcome to Squash Bugs and Conquer Challenges Creative Problem Solving. I'm Marin, aka Algorithmer on the Scratch team. I'm a learning resource designer for Scratch, and I'll be your session facilitator today. A copy of the slides I am sharing in this session is available on our website in our learning library, where you'll also find many of the resources I'll link to today. This is the sixth in our series of 6 sessions on leveling up with Scratch. Each session focuses on a different topic, and my goal with each session is to give you a variety of ways to approach creative projects on each of the 6 topics. The Scratch Foundation is grateful to AT&T for its support of this workshop series. We have partnered with the Achievery from AT&T to provide free beginner and intermediate creative coding lesson plans on a variety of topics for educators, caregivers, and learners. And I'll share some of those resources throughout the session today. To code along with me today, you can go to scratch.mit.edu and click Create, or log into your free Scratch account to save projects. For anyone new to Scratch, we have Getting Started resources on our platform and in our learning library with lots of helpful information. But a few quick basics. The Scratch Project Editor screen is where you'll create projects in Scratch. If you aren't already on this Project Editor screen, click the See Inside button, which is available on all projects. Any character or object you can code is called a sprite. To code projects in Scratch, start by dragging out a block from the block palette to the script area. You can click the block to try it. Then snap another block to it to build your script. If you chose when the green flag is clicked to run the code, click the green flag above the stage. You can choose your preferred language or color mode, original or high contrast, under Settings, and see our tutorials or debug buttons for helpful tips when creating projects. When logged in, you'll also have access to Remix projects, which is making a copy of someone else's shared project to modify. I highlight some remix opportunities in this series. Or share a project that you created inspired by this series, using the share button to make your project public. Let's dive into our topic for today, which is debugging. And that's really also an act of activating our growth mindset. This session's learning goals is really to help you practice debugging and exploring strategies to get unstuck with some fun challenges. We're going to embrace playful learning and tinkering mindset values with the support of facilitation centering student led inquiry, hands on building, testing, iterating, and collaboration. And also, we always think it's nice to reflect on the debugging process. As Scratchers begin exploring computational concepts that are common in many programming languages like sequence, loops, parallelism, events, conditionals, operators, and data, they may run into common errors that will challenge their problem solving skills and then reinforce it will reinforce the importance of iteration and this growth mindset, right? If you're not familiar with growth mindset, it's that belief that we can overcome challenges, get better at what we are trying to do, and so you don't give up. It's we often talk about productive struggle here. We're going to talk about that for sure today. And that's just that act of really, these steps are important. It's important to sort of get stuck and then get unstuck. If you've joined our previous sessions, you've certainly heard me talk about Scratch's creative learning philosophy. But just to reiterate it here, as facilitators, we really want to support playful learning and tinkering mindset values so that participants can engage playfully in projects that are meaningful to them and elicit joy, collaborate with peers to experiment, share, and celebrate ideas. This allows for multiple pathways of engagement to foster a wide variety of projects and support different experience levels. We'll be talking about that for sure today. We'll also be focusing a lot today on developing that mindset that is comfortable with the discomfort of getting stuck, making room for risk and iteration. And then also developing a mindset that thinks critically about strategies for getting unstuck. So, saving space in the process to start again, help them imagine what's next. That productive struggle piece that we were mentioning. I do want to take a moment. I feel it's important always when we are talking here to emphasize that as a facilitator, you don't have to be a coding expert. So if you are worried that you teach another subject that you didn't get a CS degree, but you are being asked to maybe involve coding in your subject matter within your class, it's okay that you aren't a coding expert. That's fine. You don't need to have all the answers. One of the things that we'll talk about a lot today is this collaborative experimentation that we think is really key. And the other thing to keep in mind is that even the most experienced programmers need to debug often, and they also have to practice that growth mindset. So I think it's really important to level set that answers can take time. Sometimes spending too much time focused on an issue can be counterproductive and frustrating. So, I always like to remind people it's good to take a break sometimes and step away from the screen to clear your mind as you're trying to debug. Because I certainly find that often after some rest and focusing on something else or getting a cup of water, I can then approach the problem with fresh eyes, and that is really helpful instead of just sort of sitting and stewing in the frustration, right? So definitely good things to keep in mind for ourselves and good things to keep in mind and remind our learners about. Answers may not come right away. Sometimes it's good to step away and take a break. And you don't have to be an expert. We all grow, and many of us come back and look at the code we wrote a long time ago and think, oh, why did I do it that way? Right. But it's all that growth process that we are encouraging here. So, with that in mind, I also find it valuable to remember that we are learners just as much as our learners. And so we need to give ourselves that grace through this process that we are likely encouraging our learners to give themselves, right? It can be really powerful to model getting stuck, debugging, and iterating alongside your learners. It can also be really valuable to have learners work in pairs or groups so that they can help each other through debugging. I encourage peer to peer conversations. So, one example of that is ask three before me. The idea of that being that you ask three peers before asking a facilitator your question. And why I love that is that teaching others can really be a powerful way of solidifying information for yourself. So, in a selfish way, me explaining and teaching to others helps me get smarter and stronger in those skills for myself. And I will say that I also find that scratchers really love the ability to teach me as the facilitator, as the scratch team member. They love to teach me what they know. And that opportunity to have your learners get that chance to share knowledge, I think is really wonderful and powerful. And I would encourage you to remember that you don't have to have all the answers. Maybe a classmate could be a really helpful source of information or has a different perspective on the issue. One of the things that I had a lot of fun with in the past was we had this scratch event called the activity swap. And in that activity, we'd encouraged users to create projects to share with each other. And so they could be project like activities that they were encouraging other people to try, but it could also be tips and tricks that they've learned from their time on Scratch that they want to share with others. And when they have to create a project that explains this tip and trick, this cool thing that they learned, again, that's reinforcing that concept for them. They're learning really valuable communication skills to get the proper information across to these fellow learners. It I notice it kind of gives them a lot of confidence and empowerment when they're able to teach somebody something, and it was a really fun activity. So, if you are looking for something to do with your students on Scratch, maybe you have students that have a lot of experience and you're feeling like, "Oh, I don't have an activity that's challenging them." This could be a really fun idea, and, you can find a lesson plan about that activity swap activity in our learning library. So if you were curious how we set it up and a bunch of different example projects that we've provided that we thought were really great, if you go to our learning library, which I will share links to throughout this presentation and at the end, check out that activity swap activity. It's another example of sort of teaching others the things that you know and tips and tricks. And honestly, sometimes even if I know the thing, they just get so much joy from sharing it with me that I am happy to play dumb and pretend I've never heard a thing before because you just watch their eyes light up and it's just really powerful. So model getting stuck, model that debugging that we're going to practice today. It's very powerful to see that even our our facilitators, our teachers, folks that have a lot of experience with Scratch are always still exploring and finding something new. That includes me as a longtime Scratch team member. For those new to Scratch, I also note that it is helpful to let users get stuck and experiment a bit with the blocks before sharing tips and tricks. Obviously, my job here at Scratch is often, as a learning resource designer, is often to share tips and tricks. But in an environment where I can be working with folks one on one and we can scaffold and be going through lessons, one of the things that we really encourage is to start with not sharing those tips and tricks, but experimentation. So, in a blog post titled Start with Exploration, Not Explanation, Natalie Rusk, who is a research scientist and was one of the creators of the Scratch programming language, shared this lovely observation. She said, young people who have developed broad creative, computational, and collaboration skills with Scratch usually first learned by playing or messing around with it, trying things out and seeing what worked. This playful approach helped them build their confidence in their ability to learn and problem solve. And I love that. With that in mind, we really say hold the tools as a last resort. It's really tempting to sometimes grab the mouse, show them how they could do it, grab a block. But we encourage you to try maybe describing steps before doing it. Let them control the mouse, let them control the tool. That again helps reinforce learning for them. And then if you do need to navigate the tool, let them try for themselves after you've shown them or guided them along, or maybe have them talk through the steps they think you should take. If you've heard of pair programming, where one person sort of controls the tools and another person is guiding and helping that person discover which blocks to use. This is sort of the reverse. They could program you. You could be the computer navigating the tools, and they could program you if maybe they have issues trying to navigate the mouse or the keyboard keys. So different ways that you can attempt this, but really try to let them lead. We often describe this facilitation technique as keeping our hands in our pockets, and I really love that visual. And we literally will often sit around in person sessions with our hands in our pockets because we know it can be tempting to grab those tools, but it's really great to let them navigate these things themselves. One place where scratchers can get tripped up when starting out is that there are blocks that are similar but different. If you've ever worked in Scratch, you've probably seen some examples of this, like a set block versus a change block. Or in sound, there's a play until done versus start. Rather than quickly debugging by highlighting these alternate blocks and noting what the difference is, I think it's great to first pause and encourage them to look around at the options and experiment. Again, this is sort of hold the tools, keep your hands in your pockets, let them navigate. Look through a certain category of blocks. Is there anything there that might look similar, that might handle things differently. Let them do the finding rather than you saying, "Oh, there's another block that could do that," right? So we explore this in an achiever unit that we have called Similar but Different. Achievery, for those who are unfamiliar, is a free website that you can sign up for from AT&T, and Scratch has provided a number of different units there covering a variety of topics. And I'll give you a slide and some more information later so that you can check these out yourselves. But one of the units that we have there is the Similar but Different unit. And I like to start this activity again, kind of not only myself hands off, but everybody hands off. So the first thing I will often do if I have similar looking blocks is say, okay, let's examine. Let's look at the blocks or the code sequence. Now let's make a hypothesis. So before you test the code by running the block or the code sequence, maybe write down or say aloud as a class what you think the difference is between these. Now it is time for observation. So now let's drag the blocks out to the script area and try running them. And then what differences did you observe? Was your hypothesis correct? And there's also the part of this that is use cases, because each block could be useful in different circumstances. So there may be a circumstance where you would want to choose one block over the other. Maybe the difference wouldn't be dramatic, but sometimes it could. So it's always really helpful to keep in mind as we're doing this, as we're debugging, as we're problem solving with our students, that there are often multiple pathways, multiple code sequences that could lead to the same or a similar endpoint. And so that is why when deciding which blocks to use to create a sequence in Scratch, we encourage that experimentation. As learners iterate on their code, they may think about similar sequences that could make their code more efficient to write or to edit, or maybe be easier to understand. Some contexts may benefit from one block over the other. So comparing these similar but different solutions really provides an opportunity for collaboration, giving and receiving feedback, and seeing from another point of view. Another scratcher may see a different path, and that's an opportunity for us to learn from each other. Why did you choose that path? Why did I choose mine? And again, we're not necessarily promoting that one is better than another or one is the right solution versus the wrong solution. It's just a matter of, is it accomplishing your goals? Is it accomplishing what you want in the program? And then we can do things like refine to make things faster or easier to edit. But if it's accomplishing the goals, that's the our goal. Right? Similarly, code sequences, right? Sometimes it's blocks that can be similar but different. But then there's also code sequences that could be similar but different. And so one of the units we have in the Achievery is called the Code Reading Challenge. And this could be a really fun idea for you to create for your class, have kind of a debugging day perhaps. And what you want to do is try creating a code reading challenge where you have similar but different sequences. And then we can ask our learners to determine which code sequence matches, say, a video clip. In this particular unit, we've got 3 video clips and then we've got 3 sequences. And we say, okay, before you run these in Scratch, before you recreate these and touch the code, again, we're doing that sort of hypothesis and then observation. So once they've determined which one they think matches, maybe even before testing it, ask, what clues did you use to match a code sequence to a specific clip? Was the end result dramatically different between these different sequences, or was it pretty similar? And then when might you want to use one solution over the other? So it's a really fun way of exploring that concept of multiple solutions in a very visual way. And it's also an interesting challenge for you, I think, as the facilitator, for me as the facilitator, to come up with these similar but different coding sequences that you might try. So really fun. I definitely encourage you to check out that unit and try to create one of these challenges for your learners. But there's a handy example there. When you see inside another Scratcher's program to understand how it worked, what you're really doing is breaking that apart, right? Decomposing their code. And I think one of the things that is wonderful is if a Scratcher has provided helpful information, maybe on the project page or in comments in the scripts area, to help others understand their code. So I encourage you to highlight this opportunity as an idea for your learners when they're sharing their code. You can see examples of this in action in many of our starter projects. So if you go to our starter projects link, you'll see a number of examples of the team trying to model leaving comments, whether it be ideas about how you might remix or change the code, or little notes about why a specific block is where it is or what it does. To comment the code in your project, you can just right click on a specific block or just generally in the script area. And then you're choosing that add comment option that you see highlighted in this slide. I also personally find comments to be very helpful reminder for yourself as to why you chose the solution you did or how a complex script works. Because often when you stepped away from something and you come back to it later, I don't know if you have found, but I've certainly found that sometimes I think, how does this work? I need to make a correction, but I don't remember how these different scripts are connected, or what is being triggered here, or why I chose this particular similar block over another similar block. And so, not only can the comments be helpful for others trying to come in and understand your project, but selfishly, it can be helpful for you as well when you pick this back up again to remember what you did and why. In this example that I've got here on the slide, I was explaining what the abs block does, and then why I used it the particular way I did in the script. But comments can be simple, short. They don't have to be this long explanatory, as I've got an example here. But again, just really helpful. And in written programming languages, there is the ability to comment code to sort of have text separate from the code that the computer doesn't run, where programmers will leave themselves notes about why or how things are connected. So this is a technique that software engineers and developers use all the time. So here's a wonderful way of testing that out within your Scratch project. I mentioned many times now that there are often different pathways and multiple code sequences that could lead to the same or a similar endpoint. So, in the blog post, there's more than one way to code a cat, which I love that title. Natalie Rusk shared this quote. She said, "Before responding, I find it helpful to ask what they have in mind so they can think about the process. Talking out their idea is often enough to help them figure out what to do next. It's interesting how often students will come up with a way to code that is different than the one I might have suggested, but ends up working the way that they want. Focusing on a single pathway not only limits the creative potential of coding, it also limits who becomes interested in coding and decides to learn more." And I think we probably all relate to that, because if you're passionate about something and you're just getting started and someone immediately sort of shuts you down, no, that's not the way I would do it. I would do it a different way. Why are you doing it that way? That's wrong. It really deflates you, right? And you may not be as interested to come back and keep trying and have that productive struggle. And so, by encouraging and reminding both ourselves, our learners in the classroom, that there is more than one way to code a cat, it encourages us to have that growth mindset, to try different solutions, to try different things, and to remember that, again, there's not necessarily a better solution or a worse solution. It's all about context. It's all about us growing and having experience. And so I really encourage that experimentation. Celebrate that variety of solutions. So everybody's project might look and be coded inside slightly differently, but they're all maybe accomplishing that same goal, and that is the idea, to get a cat from point A to B, and however that happens, with a glide, with a direct go to, with moving 10 steps 40 times, whatever it is, those solutions have accomplished that ultimate goal, and that variety is awesome. Uh, it also really gently encourages participants to move out of their comfort zones. They can try new activities and concepts. Maybe remixing other people's projects could be a way to explore these new ideas. So, if you have students in the class that have all tried something, now try remixing a project of someone else in class, or another project that you found on Scratch, and see if you can come up with a different solution of how you would approach this. Remixing is a really nice way of trying different things. I love to say, have a gallery walk, maybe, or create a class studio. It's a nice opportunity to see how others have approached similar coding challenges. In order to have a class studio, just a note, you do have to have a Scratch account and be accessing the online community. But you could set up gallery walks and studios offline as well if you want to just have them within your classroom. Students could just share projects and physically walk around from computer to computer. You could display projects individually on a screen as you all are looking through them. You could share projects in a Padlet. I've seen that, from folks, or use the various tools that are out there, even Google Classroom, right, to share links that others can see. So lots of different ways that you can share projects and explore each other's coding solutions. And then, maybe does a learner's program involve extra, possibly unnecessary blocks? Does something not work quite as desired? That's fine. We want to celebrate these opportunities to iterate and to try something new. And often just that trying something new is what we want to celebrate. Maybe the end result didn't quite work out, but they tried something, and we want to celebrate that fail first attempt in learning, if you've ever heard it described that way, right? And now what do we try? Now how do we reiterate? Now how do we iterate on what we've done? The Scratch Design Journal that I have linked in this slide can be a lovely place to help students imagine, plan, iterate, and reflect through all these phases of the project's development. I think it could be a great place to record reflections and maybe the debugging steps that they attempted. You'll find a page in there about debugging where they can sort of check off maybe the techniques that they used when they were trying to debug. Or you might leave early experimental scripts in your project with comments about why it didn't work or why you chose a different solution. So there's lots of ways to communicate this information about how we've grown and changed and iterated on our project. While there isn't version control in Scratch projects, I will just say as an aside, one way that I've handled that sometimes if I want to see that growth is to have them save uh, versions of the program. When you are in the Scratch project editor screen, there's the option to save the file to your computer. You can have them save the file and date it. And then as they make updates, again, just sort of save the different versions. And then you can always load them uh, back to Scratch from your computer and see that growth, see those different versions. So if version control is something that you are interested in, and is a technique that professional programmers use, that is my workaround and how I often do it. If I've gotten to a really good place in my code and I want to make a dramatic change, but I don't want to, I'm worried I might break everything, I will often save a version of it to my computer, and then I can feel free to explore, make changes. And then if it just totally blows up and didn't work out, I can always go back, load that older version of the project from my computer back to Scratch, and start again, try again. So Again, just some techniques that I have tried in the past that might be helpful. Another thing that I encourage you to do is to maybe consider creating a small coding challenge that can have these multiple solutions. I think it's a fun opportunity to see these different ways that learners approach a similar problem and can really generate a lot of classroom or peer to peer discussion and reflection. We have an example of that in our Scratch Achievery unit called Coding Challenge Part 1, 2, and 3. This is a series of challenges where we are investigating ways to trigger events at specific times in a program with greater accuracy. We added a appearing sprite and visual effects to as the backdrop changes. And then finally, we make the project interactive by giving the user more control over the direction via question and answer. Where do you want to go? And then you can go to that specific location. So each of these challenges increases in complexity, and it's a great example of there's lots of different ways that you could approach this. All of these challenges again will be in the PDF that you will receive at the end of this session, and definitely explore this, and then think about how you might create your own versions of this. Right, this is a start, but maybe you want to create your own challenge, and I really encourage you to do that. If you're logged into your free account on the Achievery, if you sign up for the Achievery, you can sign up for free, have an account, and that lets you download the lesson plans that are there. And what you'll notice when you download this particular lesson plan, you'll notice that I've called out some possible solutions. So I want to highlight that word possible because there could be, again, multiple ways that you can approach this challenge. Possible solutions are really just there to give educators, especially those new to coding, maybe coming from some other subject areas, some helpful hints. But again, I just really want to be clear this isn't the only solution. The solution that your learners may come up with could be dramatically different, and that's okay. It doesn't have to match the one that we have there. So, possible solutions, multiple options. But again, just this is a really bare bones challenge that can be approached from lots of different directions. And so, so something I'd encourage you to try out with your learners. I've been talking a lot about debugging. Just to define it even more clearly, really debugging is finding and fixing issues or errors in your code that result in it not working as expected or at all. Issues are often called bugs. Grace Hopper, a famed computer science pioneer, told of a literal bug, a moth, that caused issues in a computer operating system. It couldn't operate correctly because the moth got inside the machine and needed to be removed, debugged. If you haven't explored yet, we actually have a debugging module now in the project editor. So you can see it there on the screen. You're looking for that little bug icon. And when you click on that, it shares a number of strategies that you can try as you are debugging. We've actually got also kind of an expanded version, a longer version of these in our learning library in some printable posters that you could print out for free and hang around your room. There's different formats of it in there. So it's just really helpful when students are thinking about debugging sometimes to just have a few ideas of where to even start because it can be intimidating to start. So I would encourage you to check out that module and read through those techniques. But what I want to do for these next few minutes is just explore some of these debugging tips in action because I'm a visual learner. I always find it helpful to see things. So in the following slides, what I've done is I've got 3 challenges that we'll try. And after each challenge, I'm going to share why we like this challenge. And then hopefully it will inspire you to create some challenges of your own. As you've noticed as you're going through this, what I'm trying to do is sort of set the scene, give you some examples, but I'm encouraging you to create your own. And it's it helps me grow as a coder, to create these, and yeah, it's a lot of fun. So here is our first debugging challenge. This is in our Achiever unit called Debugging Challenge the Batter. And what's happening here on the screen is this program. What we want is the batter to approach the plate, swing at the ball, and then every time the program is run, we want that batter to start from the right side of the screen in a batting stance. And then once at the plate, each costume should be seen clearly. The costume changes, we should be able to follow them with our eye. And then when we hit that green flag again, that batter should return to the start, the right side of the screen in that batting stance, and the whole program runs again. If you notice in the GIF on the screen, what's happening right now is that the timing of the pitch and the swing are off. And then when the code sequence is run again, that batter is at the plate way too early and swinging in the wrong order. So the challenge in this one is, can you debug this sequence and come up with a solution so the batter approaches the plate each time, swings in the correct order, and the costume changes can be seen better? I've given you some code in a Scratch project so you can see this in action and try this for yourself. That is linked in the slides. One thing I will say is I have shared some possible solutions in the unit materials, and inside this project, you'll see a sprite called Possible Solutions. So don't look at that yet. If you want to, don't cheat yourself. Try this out. But again, that possible solution is just a possible solution. There could be many pathways to accomplish what we want to accomplish here. Here is an example of a possible solution where we have a code block to establish that initial starting place and a block to establish that initial costume at the start of the sequence. So you notice there's now two new blocks in this coding sequence that reset our character every time the green flag is clicked back to the right side of the stage and back to a certain costume. One other thing that you'll notice is that we have added a small wait between each costume change. That's really just to slow down the action so our eyes can see those changes of costume more clearly. Sometimes these blocks can run so quickly that our eyes don't have time to see the action. So the wait is there just to slow it down so we can see what is happening. So why this challenge, right? Well, one common issue that scratchers often face is the need to reset the scene when the program runs again. There are some coding programs, for instance, Scratch Junior, where the scene can reset by itself. But in Scratch, that doesn't necessarily happen. If you refresh the whole window, that would be one thing. But if you just keep hitting that green flag without refreshing the whole screen, the program is not necessarily going to reset itself. Uh, the scripts don't automatically reset position, visibility, their costume. We have to think like a computer, right? This is a great opportunity to think like a computer. The program only knows what to do if you give it specific instructions. So if it hasn't been told to reset the character, it won't. It's that sort of peanut butter and jelly coding example that I'm sure many of you are familiar with, where you're trying to help somebody code a peanut butter sandwich. Or there's a fun little book called How to Code a Sandcastle that I love, that also is the similar concept. But the idea being you have to be very explicit about what you want, and you have to be really clear and give those instructions in order. Because if you don't tell it to do something, it won't. So if you don't tell it to open a peanut butter jar, it won't, right? So you're just stabbing at it with at the top of it with a knife, right? The action of the program, as I said, can also just move so quickly that slowing down that action can make it easier to see what's happening and therefore easier to debug. So, two debugging strategies that are listed here are ones that I use a ton, which is to slow it down or to add sound checkpoints. Um, this sound checkpoints was suggested by an educator a number of workshops ago, but I love it because sometimes hearing it is maybe easier for somebody than seeing it on the screen. So if I run my code and I say, squeak at this particular point, if it never squeaks, then I know something has happened before that. Or if it squeaks and then the problem shows up after the squeak, then I know that's the part of my code that I need to check after the squeak. So it helps break up where the issue could lie to make it, less code that you have to debug, right? So some really helpful techniques there that I would suggest, slowing it down or adding sounds to help you pinpoint those issues. This is our other second achiever unit called Debugging Challenge Cat and Bug. So in this program, what's happening is we want a cat and a ladybug to interact. So every time the program is run, we want the cat to spin in a complete circle while staying on the ground. Cats can't fly, believe it or not. So stay on the ground and then move to the ladybug. And then when the cat reaches that ladybug, we want the ladybug to play a sound like, hey. Now, currently what's happening is the cat is moving in a huge circle that ends in the sky. That's a problem. And it never moves to the ladybug. I'll show this on my tab in a second, but you will hear that the other problem is that the ladybug plays the sound hey right away instead of playing that sound when the cat moves to it. So what we want to do is debug this sequence and come up with a solution so that cat spins on the ground and then moves to the ladybug. And then the ladybug says, hey. Again, you could recreate this code for yourself, or we have code here, an example project where this code is in place if you would just like to try this out. And again, there are possible solutions that I've included in the project and in the unit, so don't peek if you don't want to spoil it until you've tried your own solution, but these are just possible solutions, not the only solution. Here we go. I'm going to run this code and you can check out the bug and the cat and let's see what happens.
Hey.
Right? So bug said, hey, right away, cat's in the sky. I'm going to run it one more time.
Hey.
So not the solution that we are going for. We want that, hey, you bumped me to happen once they actually touch, and we'd like the cat to stay grounded. In this example solution, what we've done is we've placed the move 100 steps block outside of the loop and after the loop. And then in this case, for some really exact timing, I've used a conditional statement, wait until touching cat. And that was added to the bugs code. So one is the cat's code, the other is the bugs code. Sequence and block placement are important, especially when using loops. These are often something that tricks up students. So that is one reason why I really love this as a challenge. So that cat sprite, right, when the move block was inside the loop, the action was being repeated 10 times and the cat was moving before each smaller turn rather than moving once after all the turns. So order and placement inside versus outside the loop really made a big visual difference here, right? And just that small movement fixed the problem, right? It wasn't even that dramatic. And then timing events for different sprites is also a really wonderful example of multiple solutions, multiple ways to approach this. So to time the ladybug to say, hey, at the right moment, you could add a short wait block before the sound plays. Now, the time chosen may vary depending on the preference about how soon the sound is heard or the length of the sound clip, right? So if your sound is 2 seconds versus 3 seconds, we'll have to adjust that wait time. You could also use a conditional statement like I did. Wait until it's touching the cat, since the goal is for them to end up touching at the end, then that should be able to trigger the action. You just have to get the cat over there first by fixing the cat's code. You could also use a broadcast. So maybe when the cat's code has finished running, you could have it broadcast a message that then the ladybug receives, and then it plays the sound. So there's 3 different solutions to deal with this one issue, and they are all valid and they all have great use cases. Some of them may not work, right? My conditional statement won't work if the cat and the bug never touch. So if I don't fix the cat, that solution is not going to work right away. The wait is great, but if I time it wrong because I don't think about how long my sound is, there's another debugging opportunity that I have to figure out, well, how do I adjust that time, right? So lots of different use cases and reasons why we may choose one over the other. So 2 debugging strategies listed here: to loop or not to loop, to tinker with the block order, other strategies you may have to try this solution. But let's go on to the next challenge. This is our 3rd challenge in the series. We're gonna, this is called Debugging Challenge Color Coral in the Achiever unit. And in this game program, what we wanna do is have a player try and stop the fish from reaching the pink coral by moving the diver up and down to block its path. And so we're using up and down arrow keys. And every time the program is run, we want to have the player lose 1 point when the fish reaches the coral. We only want to have them lose 1 point if it touches the coral. But currently what's happening is the diver sprite's working fine. It can be moved up and down, but the fish resets back to the left side. That's great if it touches the diver. So it's blocked from reaching the coral. The problem is that once it touches the coral, it starts losing an insane amount of points. We only want the player to lose 1 point. So it just keeps losing just hundreds of points. And the other problem is, if you notice here, as it's touching that starfish just now, the other problem is that the player is also losing points when the fish is touching a starfish, which is also pink. So how do we combat that? You can, again, recreate this code yourself, or you can see the code in action, the code that's linked here on the slide. But how might we solve this? What I have done here with this possible solution is added a second parameter requiring the fish must be touching the color and that the fish must be above a certain height on the stage. That way it ignores the other pink element on the stage, the starfish, that is lower on the stage. I also added a small wait block to pause the script until the fish is no longer touching the pink color. We could have it pause with and not use the not touching, right? That's a kind of an advanced block. Wait until not touching. You could wait 1 second. You could lots of different we could change the color of the starfish. Right, that could solve the solution. We just recolor an element so there's no other pink elements, right? Lots of different ways that we could approach this. Why we like this is that touching color uses a Boolean block to determine if the fish is touching the pink coral. Boolean blocks, if you're not familiar, they report values as true or false. So if a sprite is touching the color in this block, the block will report true. And if it isn't touching the color, it will report false. And then this is information that we can use to understand where the program sees the sprite touching the color you've entered so that you can debug issues. So one of my favorite creative solutions is to get a constant reading on what the value is in that Boolean, that's true false statement at a given time. So what I will do sometimes is place the variable reporter or the Boolean inside one of these say blocks in Scratch. I'm going to have the program help me debug. I'm using the actual blocks in the program to give me this information. So if I put a say block inside of this forever loop, what it's going to do is it's going to continually report the updated value as it changed. So in this case, is it touching? Is it touching? Is it touching? Is it touching? it's constantly telling me true or false. And so if I try that out, what I can see is that it'll tell me true, 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 or false, 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 true when it hits the starfish, and then I know, oh, the starfish is reading as that same pink color, and that is what's causing the issue here. So make the program help you. You can also notice the location of the different pink elements on the stage. So, like I said, I've adjusted it so if the fish is above a specific height and it's touching pink, I added two parameters, then it happens. So there I could leave the starfish pink. I don't even have to worry about if it reads the starfish as true or false pink because it's only looking above a certain height. So lots of different ways that we could approach this. And like I said, that wait until is maybe more advanced. Maybe you want to try a different solution with this. I hope that you are interested and really inspired to create some of your own challenges. And we would always love to see them if you want to share them on Scratch and share them with us. When learners are faced with problems or bugs in their code, it can be really tempting to give answers to questions right away, or you may not even have the answers, right? So, one of the things that I encourage you to do is to ask questions instead of providing answers so that learners can arrive at their own answers. If you don't know right away why something isn't working, asking these questions out loud gets you both involved in thinking about this. So you can try the prompts listed on this slide to support participants and deepen their critical thinking, their self efficacy, model that collaborative problem solving to help them get unstuck when faced with program bugs or challenges. And like I said, these are just a few examples. If a student is debugging projects while on their own without a peer or a teacher to turn to, something like rubber ducky debugging, if you've ever heard of that, could be really helpful. Like I said earlier, even the most experienced programmers need to debug often and practice this growth mindset. So, rubber ducky debugging is really a technique that software engineers have used, wherein a programmer explains each step of their code in natural language, ideally aloud, and then they think from the computer's perspective. So, are you including steps that aren't there when you're talking it aloud? Are your instructions clear? If something needs to be reset each time the program is run, are those instructions included? Explain to this object, could be any inanimate object like a rubber duck. Here I've got my own on my desk. I have multiple rubber ducks. Here's my Lego duck. Here's my rubbery duck. I even have a Lego duck in a thing. And I don't know if you can see behind me here, I've got a very big Lego duck back there too that I can talk to. I have a big problem. But the idea is that when you are talking this through aloud or explaining it to someone else, even an imaginary someone, it can be really revealing and help you find where the errors are. And then, of course, reflecting on the debugging process itself can be a helpful activity. So, we have debugging reflection sheets in our learning library. Take turns talking to a peer, talk about what challenges came up for you while you were creating this project. How did you get unstuck? What strategies did you use? Did you have moments of frustration? What techniques did you use to manage your emotions and your levels of stress in those moments? If you can't debug on your own, who can you turn to for help and advice? Where are trusted sources of information? Examples could be our Scratch Learning Library, the Scratch Wiki, which is created by volunteers, tutorial videos like we have on YouTube, asking for assistance from other Scratchers in comments or studios. And then when you're preparing to debug, what are your strategies to keep track of your changes, right? Maybe how are you noting what worked and didn't work? Are you writing it in the design journal? Are you adding comments for yourself within the program? Are you saving versions of it on your computer to look back through later? So lots of different ways that you could practice and be able to refer back to what you did. And then, how did you attempt to fix the code? And then not forgetting there are those many pathways, right? And so compare your code with other solutions. Maybe it was similar, maybe it was different. Why did you choose the blocks that you did, right? And so keeping in mind, we can keep iterating, we can keep growing. Maybe it requires another bug of bug hunting after you've iterated, right? But that reflection process about debugging can be really helpful. As we think about creating, iterating on our work, or debugging, keep in mind that pair programming can be valuable, especially when you have groups of different experience levels or interests. Pair programming is a practice where two developers collaborate, sharing a keyboard and mouse to work on the same task or project. One person is the driver who creates the code, while the other is the navigator who reviews, guides, and thinks strategically. Roles are then switched frequently to balance tasks and share knowledge. Together, the pair can create rich and dynamic projects, while they have opportunities to teach and learn from each other and explore different solutions. The pairs could divide up the tasks in a project. A student interested in art might create sprites, or a student interested in music or Foley might create sounds or musical scores, while another focuses on coding. Or students could pair up at specific moments to debug or add additional elements together. In addition to the resources shared throughout these slides, I've shared here some additional resources where you can find help, inspiration, and information. Dive into our learning library for a wealth of materials that continues to grow. I've mentioned resources on the Achievery during today's session. The Achievery platform connects K 12 students to a new world of digital learning. And the Scratch Foundation is partnered with the Achievery to provide free beginner and intermediate creative coding lesson plans on a variety of topics for educators, caregivers, and learners. On the platform, there are project guides and accompanying videos that support the exploration of Scratch. Lessons are perfect for those who may want more guidance or scaffolds to start. And Scratch units cover a variety of topics, so students can take the skills they learn and create projects about things that relate to their passions and interests, while engaging in playful exploration. You can sign up to access for free on their website. Thank you for exploring this webinar and our resources today. I hope today's session has sparked ideas and will inspire your own unique projects that speak to your passions and interests.